Let's go. So guys, welcome to the presentation where I'd like to give you a brief introduction to Go and see what it has to offer for us and how it compares to PHP. In this presentation you will see a bunch of code, so just to give you an idea of how it looks like. Actually, you don't have to fully parse it in your head, just look at it, get some impressions, and see how it goes on from there. In this presentation, I will not talk about how to create like variables or functions in Go. I think we're all experienced developers who already know the concepts behind that, so that's pretty trivial. All right, so here's the agenda. We start by taking a look at some basic facts about Go, then dive right into some code examples so you get a good feeling of how Go code looks like and what it is really good at. We then move into the beefier parts where we compare PHP to Go, followed up by some performance comparison, and then I want to show you some more nice things about Go, take a look at some companies that are using it, and finally question if Go would be a great fit for. So, like TypeScript, Go is a statically typed language, which means it checks for errors before you run it. Go will compile into a native binary executable like you know it from C or C++. So on Windows this would be an .exe file. It was started by three geniuses at Google about 13 years ago, namely by the guys who created the Java virtual machine, UTF-8 or the Unix operating system. So their idea is they wanted a language which is really simple and works great with large teams. And languages from the past were designed to only run on a single CPU. But as we're now in the modern age of cloud computing, they saw an opportunity to leverage that. So they created Go, which now powers a huge amount of web services at Google, Netflix, Facebook, and many more. All right, to start off, I would like to show you a few code examples of Go so you get a good feeling of it. And this is our obligatory Hello World program where we just print some text to the terminal. At the top here, we declare the package the code belongs to. So in PHP, this would be the namespace. Then we have the imported packages. In this case, it's just the formatting package, and then followed up by the actual Go code. So some of the slides here have this run button, which allows me to run this code right in the browser. And if we press it, yeah, we get the message, "Hi mom." So nothing too exciting here, but let's beef this up a little and create the hello world of the web. So here we can see how easy it is to create web service in Go. First, we register a new route and pass in a function which outputs our text to the HTTP response. Below that, we then start an HTTP server on port 8080. Now we can run this and probably have to change the ports here so we don't get any conflicts. See no output, but if we now go to localhost port 8081, yeah, we can see our message, "Hi Dad." Pretty small, but good enough. So let's close this up again. Yeah, if you ask me, very nice what you can do in a few lines of code. And there's also to note here that this is not like your PHP or Node development server. This also does not require an Nginx in front of it or something like that. You can run this on a Linux server with no configuration at all and have a very high performant production grade web server which even supports HTTP2. So what is also quite handy for building websites, yeah, templating. So Go has also a templating language built in, which is quite nice. You can already specify the HTML code right in the code here or read it from a file. And then it parses it and then renders it here to the standard output. And if we run it, we can see our HTML and you can already see that it keeps out bad people trying to hack our website. So there's already sanitization, yeah. And with a simple change of this HTML here to, for example, text, and we run it again, you can see we've just now changed it from HTML rendering to basic text rendering, if that matters to you. Instead of HTML, Go of course can also render stuff to JSON, but that basically looks like the example we've seen here before. So as SQL databases are very common for web services, Go of course has also one of these clients built right in. In the first snippet here, we can see how we can connect to a database, and then you can insert a row into the users table like this, and then lastly query and back like this. So usually with just a web server, templating language and a database client, you can already build most of the web services you can imagine. As I've mentioned in the beginning, Go was designed to work on our modern age of cloud computing. So let me show you how parallel processing or multi-threading is baked right into the language. Here we have a small program which fetches 3 websites, grabs the body and calculates the size of it. This is how we would probably do it in any language. You make a request to the website, do the processing, and then start the next request. And to see how long this would take, we can simply run this code here a couple of times. So we first grab Google, then Facebook, Instagram, YouTube, and then it took us like 2.5 seconds. It's pretty slow actually right now. Yeah, 1.1 second, 1.3 seconds, so averaging about like 1.5 seconds, I would say. So let's see how we can parallelize this in Go. So basically this is the same code as before, but we've introduced 2 new concepts. The first one is the Go keyword. This will spawn a new Go routine in the background, which you can imagine as a very lightweight thread. It's so lightweight that you can have like thousands or even tens of thousands of them running at the same time. A couple of languages also have this concept, but usually there's no way to communicate back the result of it. So the next concept we've introduced are channels. So channels you can imagine just like a water pipe. You push in water on the one end and it comes out on the other. So to wire this all up, we create a new channel here, then pass it into the page size function, and instead of returning the result, we just push it into the channel. And then we receive it back here 4 times as we are running 4 page size queries. Then we can run it. And you can see this is already a lot faster because we're querying them like all at the same time. It takes like only 1/3 of the time. And it's even possible, if I run this a couple of times, that YouTube will probably show up before Instagram if YouTube returns faster than it. Yeah. So that has been a few code examples, and now I want to show you what there's also in Go that is really nice. So after you've installed Go to your machine, you have a complete Go toolchain available for you, and here it is what it comes with. So GoGet acts like a package manager and downloads third-party libraries from GitHub, Bitbucket, or basically any other version control system. Then there's GoFMT, which is basically the formatting, which automatically formats your code so it always looks nice and pretty. It's very nice, and you don't even have a debate about tabs versus spaces anymore, and by the way, it's tabs. So usually formatting, the formatting command is automatically hooked up to your IDE and executes automatically, so you don't even have to think about that. Go run simply runs your program, and Go build will give you this nice packaged up binary executable like we've talked before. Testing is also built right into the toolchain, which we will see on the next slide, which you can basically run with the Go test command. So speaking of testing, this is basically what a test looks like. It's just a normal Go function with the prefix test. Here we're checking some strings, comparing them. And the good thing is that tests can be written right next to the actual implementation. So here, for example, we have a folder structure where we have a foo.go file, and then a test would be in foo_test.go. So there's no split up between them. They are going hand in hand with each other. So say you want to use a Go package in your program, but the README on GitHub does not give you a lot of details on how to use it. You can simply go to pkg.go.dev, type in the package name you're looking for, and you're presented with a very nice and in-depth documentation. This is, by the way, automatically generated from the Go source code of your program as well as the comments. So there's really nothing to do for you. You can even get a documentation on libraries with no comments at all in the source code, and you will at least get the API stuff. So talking about packages, Go comes with batteries included. So you have a big standard library to work with. Basically, this is like the opposite of Node.js. I haven't counted how much there are, but having a nice standard library with all sorts of things gets you productive very quickly. And this is not like a package repo like packages or npm. This comes with Go before even pulling in any third-party dependencies into your project. And if you need anything else, you can just go get it, as the community offers a huge amount of high-quality packages. All right, enough with the nice things. Let's see how Go compares to PHP. And speaking of the safety aspects at first. So let's start with a quick question. What makes TypeScript so great? Well, it's still JavaScript, and JavaScript can be cumbersome to work with at scale, especially on big projects. So why do we choose TypeScript for our front-end projects? Obviously, it's the strong typing system, which prevents us from doing a lot of mistakes. And as mentioned, Go has these too. So how Go and PHP handle structured data? So this is the thing where we can see that we are missing the types on the back end, and this is how we can still screw up. In PHP, we usually have something like this. An array with lots of keys and lots of values. Unfortunately, no type checking whatsoever, so PHP will happily execute this code. So, looks good. Did the spot the mistakes I've made? Well, let me show you. Here, for example, in affiliate ID, I forgot the I, and is active should probably be not maybe, but something like true or false instead. So, but I can already hear saying, there's a better way to do this. So this is how we should probably do it, right? Having a data transfer object where we can safely place our values and have some type checking going on. But do we really do this? Yeah, I think not. This just requires tons of boilerplate code, which does not even barely fit in this slide. And I think that's probably why we don't do it. Also, we don't know if something went wrong until we actually make use of this class. So let's see how Go does this. In Go, we just create a new data structure and give it a name. No constructors, no public, no private, no getters, no setters. And then we instantiate a new one of this, fill in the values. So let's try to run this. Yeah, looks like we've made some errors here. So unknown field affiliate ID cannot use maybe as type bool. Yeah, looks like we've made the same mistakes here again. So if I fix these here real quick, change this to true and run it again, we can see our user has been created. So I think this type checking alone is already a huge win. But let's continue by taking a look at how PHP and Go handle errors. So say we have this function here, which applies tax on an invoice. We ask taxjar to calculate the taxes, then submit this to Stripe, and finally apply the taxes for the invoice. You can clearly see that we have no error handling in place. So if any of the services or database is down, this would fail horribly. But what do we do about this? Obviously, we surround it with try and catch. But is try and catch really good enough? Well, let's see. So here we have an example from Laravel, where we simply query for user, we get what we expect, the user data. However, when the user does not exist, we get null. So the solution goes as follows. We check if the user is null and handle the error. But what happens if the database fails? So then it behaves differently. It throws an exception instead. Alright, so our updated solution now looks like this, where we have 2 errors just for one thing. So are you really sure you have accounted for all of that in your code? Well, at least I'm not sure about mine. But Laravel wouldn't be Laravel if there was not an alternative way to do this. So instead of using find, we could, for example, use find or fail. So this would result always in an exception. But let's see. So this is our API project, and I've searched for both uses, find and find or fail. The search result speaks for itself, I think. Well, pretty bad if you ask me. And I don't think we don't handle errors because we don't handle errors because we are lazy. I think it's much rather the case that we've never got into the mindset that almost everything can fail. So let's take a look at how error handling is done in Go. Here we have a similar function that applies text to an invoice. And what you can already spot is that error handling in Go is very explicit. As Go has no exceptions, like in PHP, functions that can fail usually return 2 values instead of only one. So either a result or an error. And for each call, we check if an error has occurred and handle it immediately. So basically you're forced to check it except if you ignore it on purpose. And down below is an example from Stripe's Go library, which behaves exactly like that. We get an invoice or an error. So that's it for the error handling. Let's see how we refactor code in PHP in Go. Say you wanted to decouple the team from the user and place the lookup logic into a service class. So you start your good old find everywhere dialog, search for team, just so you don't miss out on anything. And what you get is not only what you're looking for, but also a bunch of other crap that you don't really need to care about. You would go through all the files, check if what you're looking for is correct, and adapt it and repeat. So how would you do a refactor in Go instead? Well, first you just do your change, then run the program and see what breaks. There you have a clear list of what you need to update. And when you're done, you can try to run your program again, and if there is no error, you can safely say you've found all usages. How Go and PHP handle switch statements. So this is just a small one to illustrate that the Go authors have been putting a little bit of thought into the language when designing it. So in PHP, when you forget to break in a switch statement, so for example here in case B, things might not behave like you would expect. But in Go, however, they turned this whole thing upside down. Break everywhere, except if you don't want it to, like here with the fall through keyword. And another small nugget, Go is very picky and will not let you have unused variables. So if we run this code, for example, we get the error that last name is declared but not used. And if we remove it and run it again, everything works fine now. So essentially it makes sure that you never forget to use a variable, say like in a price calculation, or tells you that you're not needing it anymore. So summing up, in PHP you can never say for sure that your code is safe. You only know you broke something when it's already too late. And in Go, however, it makes sure that you're writing safe code and you know very quickly you've made a mistake. So in essence, Go breaks before you can even compile it. PHP usually breaks after 2 weeks in production. So what does this imply for our day-to-day life? In Go, we can develop features more quickly. We have faster code reviews because we only have to focus on the logic. We should not worry about having all types correct because the compiler is much better at this. This means our code gets faster to our customers and we can finally write code with confidence again. So this has been the part where we saw how Go prevents you from screwing up. Let's now take a look at how simple it is. So in PHP, we have 64 reserved keywords in our arsenal. So just for good measure, I wanted to show you that. In Go, however, there are only 25, which already simplifies the language by a lot. Loops in PHP, you know them, we don't have to talk about that. You have one for counting something, one for ranging over something, a while loop, an infinite loop, and so on. In Go, we have these two, but when designing the language, they threw out the while for each and do while, and just stick with a for loop. All functions have been merged into one. In PHP, there are a lot of ways to define data and behavior. We have classes, final classes, abstract classes, classes that implement something, classes that extend something. Then we have traits, interfaces, public, private, for functions, attributes, and also some static stuff. Yeah, very lot. In Go, however, we only have that, and that's it. Structs for data, interfaces for behavior. No public, no private, no extend, no implement, nothing. I have to say there's something similar to public and private, but that's just a matter of your functions starting with an upper or lowercase letter. So let's take a look at this quick example, how this all comes together. At the top, we have an interface with one method, two string. Then we have a person struct with some attributes. And finally, a so-called receiver function. So this is not that easy to grasp when you first see it, but that basically just slaps a function onto a struct of type person. At the bottom here, we can see this in action, where we have a greet function, which accepts a stringable, and then we just call it with a person. So we can run this. Yep, works as expected. And as you can see, nowhere in this code do we have to say person implements stringable or something like that. But we will take a look at that later, how this can be useful. So essentially this all happens automatically. Let's compare how the deployment process of both languages are going. So in PHP, you first obviously get a server where you want to host your application on. You install Nginx or Apache, configure it, then install PHP with all the extensions. Then you allow your server to pull from your version control system. Then you do git clone, composer install, and hope you did not forget something. In Go, however, we simply just build our app, upload it to our server, and simply run it. So no dependencies, no runtime environment required, because it all compiles down to a single binary executable. So PHP is a simple language, you say. For this presentation, I've dug through the PHP RFCs and looked at all the language features which have been introduced between PHP 7.0 and 8.0. So let's see if you know some of them. So language features, so basically just language features affecting the syntax introduced from PHP 7 to 8 is like the space strip operator, null, color sense, return types, error destructuring, class constant visibility, arrow functions, trailing commas, blah blah blah, and so on and so on. And this list goes even further. And as mentioned, these are only the language features introduced into the PHP syntax in the last 5 years. This does not include like any new classes or functions or low-level features like the JIT. They are just the language words you're writing. So essentially, PHP gets more and more complicated. But what do you think how many syntax features have been added to Go? Well, basically none. And that's good. The developers or the creators are not lazy, they do this on purpose. While there have been smaller additions to the standard library, for example, improving the security aspects of HTTPS and so on, but nothing in regards of the language at all. Since the first release of Go in 2008, they made the promise that the language specification, so the things that you are actually typing into your editor, is fixed, and old programs will continue to compile on newer versions of Go forever. So one quote from Rob Pike, which is one of the creators here, is when they discussed if a feature should go into the language, is from his talk Simplicity is Complicated. we insisted that all three of us, the Go authors, not only agree with the feature going in, but agreed that it was the right feature to go in. So this essentially scraps out everything that is implemented in many other languages, but actually not very useful. So summing up, PHP has a lot of stuff and it grows and grows. So good luck keeping up with that. And if that's not already enough, you also have to learn a framework to be productive. Go, however, is very easy to learn because there's actually not much to learn. You don't need frameworks because out of the box it brings you so much to work with. And as one of the other authors said, Robert Griesmer, in one of the talks, if you know how to program, within a week you can be productive in Go. So let's quickly talk about performance. I've created a Linux server on DigitalOcean with Laravel pre-installed. I disabled all middlewares to get rid of the stuff that can make requests slow. And then I ran a benchmark with, which requested an endpoint, which returns a simple JSON object. So here we can see a chart of measuring the requests per second the server was able to fulfill. We can clearly see that Go is super fast and actually 70 times faster when compared to Laravel. While usually a single request on Laravel might take on your local machine or on a server like 30 milliseconds, under high load the average response time increases to what I've measured 350 milliseconds. Go, however, only took 5 milliseconds for a request and even goes as low as like sub-milliseconds to respond to a request. By the way, the thing in the middle here is just a simple index.php file with JSON encode and no Laravel or framework around it. And because large numbers are not that easy for humans to grasp, if you're looking at PHP, at Laravel, just imagine playing Counter-Strike on a PC with 1 frame per second versus playing it on a PC with 70 frames per second. I'm also, and this might be controversial, I'm also very certain that this is the reason why something like Laravel Vapor exists, by trying to make super slow framework somewhat reasonable in performance when you're scaling to a lot of users. So some other nice things about Go we've seen in the beginning, and here are a couple of more. So in the beginning of the presentation, we've seen the slide showing off the public documentation for open source packages. But when working on a team, on private projects, it would be very nice to have this as well. So we can simply run this Godoc server in our project and we are presented with a live documentation browser which hot reloads everything on the fly and no restart is required. So here's an example project I've created with the user API server. To be honest, this looks a bit dated as this was the first official documentation server in Go, but it gets the job done equally well. So here you can see what types the API has, what functions there are to call, and if we go to the next slide, you can see all the comments in the code and even some of the code itself. And if we wanted to see the full source code behind this, we can, for example, click on this type user here and we jump right into the source code. It even highlights it so you know exactly where you are. Profiling. So say you're very concerned about the performance of your server and want to make it really, really fast. So when building an API server, for example, you can import this net HTTP pprof package and it will make a new HTTP route available in the background. So when requested using this tool here, you can see at the bottom, it will start collecting the CPU usage for that duration you've specified. So for example, 5 seconds. So then once this tool is running and gathering, you can click around in your application and it will gather the results. And after that, once it's done, it will visualize that using a tool in the browser. And this is how it looks like. So this is one of the visualizations you can take a look at. This is an example application I can show you after the presentation, which essentially is like an API for URL shortening. You're presented with a snippet of the source code and can directly see here in line 75, for example, that the shorten function takes most of the processing time. You can even dive more into it and see here at the bottom that some of the processing time goes into finding a new shortcode that is available. Another visualization, if you're more into graphical things, is the so-called flame graph. This gives you a visual representation of what we saw in the previous slide. And while this one here is very simple, it can get quite complex, but luckily you can filter it out by just clicking on the things you're interested. So if I don't care about the runtime stuff, I can just click on URL store shorten and it will expand that, and I can see in all detail what functions are using most of the time. So enough for profiling. Another thing I find quite cool, but is very underrated in most languages, are the interfaces. So we've briefly talked about these before, and that you don't have to specify what interfaces you are implementing. So I'd like to show you what the simplicity of, with the simplicity of Go, what these interfaces can leverage. In Go, we have these very popular two interfaces, the IO reader and the IO writer, and among a lot of others. So these are basically just for reading and writing bytes. The thing is that a lot of packages implicitly implement these. So here's an example which utilizes that. When we're making a HTTP request to the DBIP server to grab the latest gzipped CSV file. So then we pipe it through a gzip unpacker, then into a CSV decoder, and finally insert it row by row into the database. And as mentioned, all of these functions implement the IO reader interface, so they are working nicely together very well. And just to make sure, this does not first download the entire file, then unzip it, then decode it, and so on and so on. This is basically like a pipeline. So we're unzipping and inserting the rows while we're downloading the CSV file. Another example that is that has a lot to do with the IO writer is that we can use it for everything. So for example, we can use it like on a file, which is an IO writer, a gzip file, a network connection, an HTTP response, or just the terminal. So this means our simple JSON encoder here at the bottom can encode the user to any of these things. And like in the previous example, you can turn this around, for example, and chain a gzip encoder in front of an HTTP response, and then you have your compressed output. Like that's especially useful for CSS and JavaScript files. So the last thing I really like about Go is that you're able to package up, for example, your entire Vue application into your Go program. This means that you can both serve the front end and the back end from the same server by just starting your Go app. You don't need to push out any HTML or Java files to, say, a Linux server. You simply build the Go app, upload it to the server, run it, and you're done. Frontend and backend ready. I will later, after this presentation, can show you an example of this if you like. Then, if you want to code Go, but you like PHP Storm a lot, JetBrains also has you covered with their Goland IDE. Of course, there's also Visual Studio Code, which I'm personally using because I'm broke and cannot afford a license. Yeah. And if you still think Go is a trend and not very mature yet, here are some companies using Go. This is just from the official Go website, but there are many, many more, like, say, Personio, which we are using, Delivery Hero, where you've maybe ordered a pizza from, Trivago, About You, HelloFresh, and so on. And some great projects which have been created in Go, which you maybe know, is like Docker or Kubernetes, or very recently the new GitHub CLI program. Let me show you how we could migrate to Go step by step. So we can, for example, set up an API gateway in AWS. point all API routes to Laravel, and only those we've migrated we point to Go. So essentially, then we have two APIs running at the same time, sharing the traffic with each other. Or even easier, we can use Go as our main API entry point, let it handle all the routes it knows of, and everything else we shoot over to Laravel as a reverse proxy. So alright, that's pretty much it for my talk. If you're now curious and want to get started with Go, here are some links you can check out. Thank you very much for joining me today. And now you can open your mics if you wish, because I would really love to hear what you think about that. And after that, if you want to stick around for a few more minutes, I would like to deploy the actual URL shortener I've developed at the weekend with you together, and we can see how easy that is. All right, thanks for your attention. That's been it.